Hey folks, and welcome to your first set of video notes. Yesterday was Labor Day, so you didn't have class, so you need to go ahead and take these notes. And what you should do is pause the video right now, go ahead and open up the note sheet if you haven't already, make a copy and add it into your physical science folder. And once you've got that done, go ahead and restart the video. So what are the phases or states of matter? The ones that we're going to focus on in this class are solids, liquids, and gases. Plasma is another phase of matter that is out there and does exist, but it's not something that we are going to be spending a lot of time on. So you don't really need to know about plasma for this class. We're just going to be focusing on the other states of matter, solid, liquid, and gas. So what are the characteristics of solids? Well, solids have a definite or constant shape and volume. What that means is that if I have a solid, it doesn't matter where I put it, it's going to maintain that same shape and size. So if I have my cell phone, right, if I take my cell phone and I stick it into a cup, let's see, do I have a cup around here? No, but I've got a little container thing, right? If I take it and stick it into the container, it's still the same size and shape, right? The shape of this has not changed despite me putting it into this container, right? That's what we mean by saying that solids have a definite shape and volume. And the particles that are inside solids are, I think it stayed right there. The particles that make up solids do not move very much and have an organized structure, and you can kind of see that organized structure right here, right? You've got this nice kind of ordered row of the atoms, and again, they're not moving very much. All right, so what about the characteristics of liquids? Well, liquids have a definite volume, but their shape can change. And so the particles that make up a liquid are constantly moving around, and that's the reason why they change. So for example, I've got a beaker of water right here. It has a certain shape as it's inside the beaker. Here's my container again that I put my phone in earlier. If I pour my water in here, the shape of the water is going to change so that it fills up the container, right? If I take the water and I pour it back into the beaker, again, its shape is going to change. However, what doesn't change is the volume or the amount of liquid that I have. I still have the same amount of liquid in here that I started with, except for maybe the little bit that's stuck here, right? But I still have the same volume or the same amount of liquid that I started with. And liquids are going to fill the bottom of any container that they are in because gravity is pulling them down, right? So all the water, all the liquid is at the bottom of the beaker because gravity is pulling them down into the bottom of the beaker, and they are going to spread out to fill it. All right, so let's talk about gases. So what are the characteristics of gases? Well, they have a constantly changing shape and volume, and that's because the particles in a gas are moving around very, very fast. They're moving around so fast that they're able to spread out and fill any container that they are in. So again, if I have a beaker, right, if I have my beaker and I put a gas in here, it's going to spread out to fill the beaker. And if I don't put a top on it, something to hold the gas in, that gas is going to leave the beaker, it's going to spread out. You've experienced that in your life. You've experienced somebody cooking, right? Maybe you've been cooking or somebody else has been cooking in the house, right? Or in the apartment, right? They're cooking at the stove, but you can smell that smell in other rooms of your home. And so since you can smell it, that's the gases. Those are the gases from the cooking expanding, leaving that area and spreading out to fill the whole container. Okay, so that's what we mean by gases are expanding, and they move very, very fast, which is the reason why they can do that. Now, we know that we have these different phases of matter, and we know that we can change back and forth between these phases of matter, right? And so it's important for you to know what these different phase changes are called. So we have melting, which is where we go from a solid to a liquid. And when we do that, we are increasing the heat energy, but notice that the temperature is staying the same. And you should have seen this when you were playing the PsyOps game, right? When you are trying to melt the alien's armor, you have to get that heat energy high enough so that you can melt all of that solid and turn it all into a liquid before the temperature will begin to increase again. And so during a phase change, the temperature does not change. Now, the opposite of melting is freezing, and that's where you go from the liquid into the solid, right? And again, During that process, the temperature does not change. Then if we go from a liquid to a gas, that is called boiling, right? That again, during that time, you do not have a temperature change. The heat energy is increasing, but the temperature itself is not changing during the phase change. Once all of that liquid is changed into a gas, now the temperature can begin to increase again. The opposite of boiling is condensing. That is where the gas is changing into a liquid. And again, during that time, the temperature does not change. Now, one thing you should note here is that the temperature of the freezing and melting is the same, right? So for water, that freezing or melting point is 0 degrees Celsius. And for boiling or condensing, it is 100 degrees Celsius. And again, that doesn't change. That's what we would consider to be a property of water. All water has that same property. So how are the freezing and melting points related, right? Well, the temperature that a substance freezes or melts is the same. So again, for water in Celsius, that's 0 degrees. In Fahrenheit, which is a different scale, it is 32 degrees Fahrenheit. And then same thing for boiling and condensing points. Again, those temperatures are the same. Okay, so make sure that you have all the notes filled out, and then there is an activity for you to do where you're going to watch some videos of some labs that I did here in class, and then you're going to answer some questions, and then you're going to submit that through Kami. So make sure you take care of that and get that all turned in. All right, thanks for watching, y'all, and I'll hope to see you soon.